How's it going, Mr. Kehs? Today I'm going to be answering the final video, Exam Day 2, Problem 1, Energy Problem. A roller coaster is currently at ground level being launched out of the station by a magnet. The 5,000 kilogram coaster leaves the station with 6,250,000 joules of kinetic energy. This is a three-part problem, so we'll be answering each part as we go along. Question 1. What is the velocity of the roller coaster as it leaves the station? Well, of course, we always want to start by listing our knowns, as we do in every physics problem. We know the initial height, 0 meters, the mass of the cart, 5,000 kilograms, the initial kinetic energy, 6,250,000 joules, and we're trying to find our velocity. If you use your equation sheet, we are trying to find velocity, and using all these knowns, we come up with the proper equation of kinetic energy equals 1/2 mv squared. Now it's just an algebraic substitution problem. You replace the mass and the kinetic energy to leave you with v squared. Once you isolate it, you should get the answer of velocity equals 50 meters per second. What is the highest hill that this coaster could climb after leaving the station? That is the second problem. Again, we list all our knowns, except this time we know the velocity, and we're trying to find the maximum height. So, because we were trying to find this maximum height, the top of this roller coaster actually has full potential energy, which will come into play in a second. So we use the equation mgh equals 1/2 mv squared. And you may wonder, we don't have a lot of these variables, but actually most of what we determined is already in Ke squared. So because we found out kinetic energy is 6,250,000 joules, we can actually substitute it here. So all we're solving for is 5,000 times 9.8 times height equals 6,250,000. Doing algebraic work, you'll find that the maximum height is 127.551 meters. Okay, and now here's the third question. At the end of the ride, the coaster needs to stop. Assuming the rest of the track was frictionless, how much energy do the brakes now need to convert into thermal energy through friction? Again, we list all our knowns, but after doing some thinking about the equation, there isn't really an equation that is necessarily as simple as using an energy diagram. In this case, I actually drew one up for us right here, but I will make it bigger so we can properly see it. We know that immediately after launch, the roller coaster has 6,250,000 joules of kinetic energy, and that energy must stay consistent throughout the entire ride. At this point, at this exact middle point, all that kinetic energy is turned directly into potential energy. So now we know that all that potential energy must go back into kinetic. And at this point, once we hit the maximum, we need to change, in order to get this to break, we need to change all this kinetic energy into potential energy. But we have to keep the height the same because it rides out. So in order to change all of that, in order to stop the car completely, we need to change 6,250,000 joules of energy into friction, or into thermal energy. So our answer is this number right here. That is the end of the video, but I also just want to say, Mr. Kehs, hopefully you enjoyed the Pallet Town theme in the background, in case you didn't know the song. And it's been a great year in your class, and hopefully I see you in AP.